Hello class, so today we'll be covering streams and files, chapter 14. So we'll be learning about basic facts about files. We'll be talking about the difference between text files and binary files. And then we'll also be talking about different ways of accessing into that file. We'll talk about stream access versus random access. And then we'll talk about how to deal with files in Java specifically. Actually, we're going to talk about text files in Java. Okay, so in general, let's talk about files. Files are basically information that a program that you run on your computer might read from. And so a file is, again, information. It's just a bunch of data. It's a bunch of really just numbers that are stored somewhere in your computer, typically in your storage devices like your hard drive, your SSD devices that hold onto your files after you shut off the computer. Data files are not part of the program. It's not part of the program's source code. They're separate. And files are read and written by programs. And programs need to understand the specific format of that file. Each file has a different format. So for example, Microsoft Word has a different file format than, say, a Google Doc or a movie file. Each one of those programs has a very specific data format for the information that it reads. It's almost like having different kinds of languages. Each file format can be read only by certain kinds of programs. And so files in general are created by the operating system. And the operating system is this piece of software in your computer that allows the computer to do a variety of tasks. And for some of the tasks that the operating system allows are file system related. So it helps it helps in creating, removing, renaming files. You could also use the operating system to organize directories, to create directories, and another word for that is folders. You can make folders and organize your folders inside of those files. So the operating system provides mechanisms to read and write files and or directories. So there are two kinds of files. There are text files and there are binary files. Remember that in a computer, everything is a number. So all files really are just a collection of numbers. And so the difference is in terms of how the program that is reading the file interprets that file. And a text file is made up of numbers that are in a very universally understood language, and that language is ASCII code. And some of you have seen this before, but here's a little table that basically shows this universal ASCII table. So for example, the letter A, capital A, is the number, the decimal number 65. Little a is the decimal number 97. So there's basically numbers associated for every single character that we might want to represent. So a text file uses this universal ASCII code. All computers around the world use this same kind of language. And new lines are terminated by a special character called \n. And so again, if we look at our table, we can find that somewhere. There's the line feed. It's not quite the same. Here's a tab right there. Line feed. There's another one for new line, but I can't find it at the moment. That's okay. Anyways, things like your Java file, a C program, HTML program, or HTML file, maybe a readme.txt. These are all just plain text files. And these suffixes that you see here, they are meant to tell you what's inside of the file, but they don't guarantee it in any ways. I could have a file called stuff, and it could have a Java program inside of it. Or just because this program or this this program has a .java, or this file has a .java suffix, it does not mean that it's a Java program. I could just have, you know, a bunch of ones and zeros. It could be a binary file, really. So the suffixes are just conventions. They don't guarantee what's inside of it. Okay, binary files on the other side do not contain text. They don't contain numbers that are in the ASCII format. It's just really a bunch of numbers. And so your MP3s, your Word docs, they will be just a bunch of numbers. And so for example here, this is a text file here, and we could see actually the information inside the text file. It's a bunch of numbers, but it's encoded in this ASCII format. So the number 54, and this is a hexadecimal number, 54 in hex is the capital T letter, and we could see that over here. We could see that, let's see, the little letter A here, or no, spaces are 20, so THIS space, IS space. So yeah, basically this is an ASCII file. Contrast that to a JPEG file. This is a JPEG file, and it's just a bunch of numbers, and you can't really tell what it's about. It's really quite unreadable unless you are a program that understands how to read this type of file. The first three numbers right here represent kind of a special code that says this is the kind of file that it is, and so the FFD8FF stands for JPEG file. So only programs that are specially designed to understand that file format can read that file format in. Okay, so those are the two different kinds of data files. Let's talk about two different ways of accessing the files. We have a way called stream access, and we have another way called random access. So stream access is this idea that we are talking with data kind of in order as the stream comes in or the stream goes out. Think of it like a river flowing down, a river of information in a stream. You know, the stream just kind of comes down the river. And so yeah, you could think of a data stream as a sequence of characters coming in one at a time. And so streams are used not just for files. I know that this whole lecture is about files, but it's also for any sort of input-output device in a computer. It could be your networking device, your Wi-Fi. The way your computer talks to a printer is via a stream of data. The keyboard itself is a stream type of device where every character you type goes to the computer in a stream of character sequences. It's very common to treat files, text files in particular, as input-output streams, just one character at a time. On the other hand, we have random access methodology. So in this case, it's not sequential. We are able to read and access any data within the file wherever it might be. And we've already seen random access in Java itself. Array lists are random access. I can get to any element very quickly. I don't have to start from 0, then go to 1, then go to 2. So any file can also be processed in a random access way. You have your choice to access a file as a stream or as a random access. Sometimes the way you want to treat the file, it kind of lends itself to one way or another. For example, a music file, you probably want to have some sort of random access so that you can kind of jump around to different songs, or maybe different parts of the song. You want to move forward, you want to move back really quickly. So just a summary, we have two different kinds of file formats. We have our text format, we have our binary format, And then we have two different ways of accessing it. We have by stream in order, or we have random access where I can get to anything at any time. Typically, text files will use a stream kind of access in order. Binary, on the other hand, I can't say there's one typical way. It really uses either way, either stream or random access. And then, I could access a text file in a random access way. It's just less common. Okay, let's now talk specifically about Java. How does Java access files? And there are actually many ways, many libraries, many classes that have been created in Java to allow you to access a file. But we're going to learn one specific way of accessing actually text files. We're going to talk about the file, the scanner, and the print writer classes. And all of these are stream access type of access to files. So here's an example of reading. First of all, I will import my scanner and file classes. Then I will specify the name of the file that I want to open. I'm going to specify the path name. And then I'm going to create a new file, which is kind of like a pointer to that file. I'm going to open up that file, and then I'm going to take that file here and then read it as a stream, using the scanner class. The scanner class is used to read the file as a stream. And so once we've opened this up, then we can start reading from it. And I've put this try catch around it. We haven't seen this a lot before, but what this does is it protects against errors happening in the program. So if, for example, this file here is not found on the computer, if it can't find it, it will cause what we call an exception, and it will then call the catch portion of it, and it will say, oh, if the file is not found, it will then print out a nice message, file cannot be found, and then the system will, or the program will quit kind of in an elegant manner. Whereas if I did not put the try catch around it and I just merely had this line, and if the file was not found, the program would just crash. So this try catch mechanism is a way of saying, well, try to do the stuff inside of these brackets, and if you get into any sort of error case condition, catch the problem and then deal with it in a nice, clean way. Anyways, don't worry too much about the try catch. This is a template for you just to kind of copy into your programs into the future. So once we've opened up this file and made it into a scanner type of object, now I have this input variable, this scanner object, that I can now start to use to read data from my file. And so we have a variety of methods. I will talk about a handful of them. We have this one called next line. It reads all the characters up to and including the /n. The next command returns a string, just like next line. It returns a string of the next word that is in the stream of characters. The next token, that's another way they talk about it. Basically, it's the next word, anything that's separated by white space. You have the next integer command, and what this does, it reads the next word first. Basically, you could think of it as it calls this first, it calls next first, and then it takes that string that it receives and converts it to an int. Okay, so let's see how it works. It's a little bit kind of interesting how it works. Okay, so suppose this is what is typed into the computer, either in the file or from a keyboard, whatever, but this is the stream of characters that is being read in. And so, yeah, pretend actually that this data is in this file, words.txt. And so I open up the file, make a scanner out of it, and I say, does the input have a next int? So it's going to look at the very first word and see if it's an integer. And yes, it is, so it's going to return true. Then I call next int. And so what next int will do is it will grab the 1 and the 5. It will grab the next word, the next token, It'll grab the 15 and then convert it to a number 15. Then, this is interesting. So up here, this was my text file, but you saw down below it was actually 15/n dog/n cat space 20. That's the text file here. Notice when I got the next int here, it only used or consumed the 1 and the 5, and the /n was not consumed. It's still in my scanner input. So now when I call next line, it's going to get everything up to the /n, and then it'll return all the characters before the /n. So it's going to swallow this right there, and it's going to return all the characters before it. There wasn't any characters before it, so it returns the empty string. So that's a little surprising. You might have thought that dog would be what is returned here, but it's not. It's a little tricky. Okay, then I say next, get me the next word. So the next word is dog, so it's going to, consume the D-O-G and return dog. And then, watch this. Is there a next int? So, the scanner object will look at the next token. The next token is actually the word cat. So it'll skip over white space until it sees the next token. So it will go beyond the /n. It'll look at the word cat and say, okay, is cat an integer? No, it's not. So it returns false. It does not look beyond that to the 20. It's just saying, is literally the next token in integer? Is the next word in integer? Anyways, those are the methods that you can use to read data. Here's a typical loop that you might have where you're reading all the characters or all the words within a file. So I create my file, make my scanner, and then I repeat in a while loop. While there is a next word, get that word, do something with that word, and then continue on checking to see if there's more words in the file. Okay, so that's the real basics of reading data from a file. Or I'm going to say even more specifically, reading data using the scanner object. The scanner object in this case is reading data from a file, but the scanner itself could also be reading from the keyboard, things that I type in as a user. So yeah, there's different ways to use the scanner. This is just one of the ways. Okay, let's finish up by talking about how to write to a file now. When I write to a file, I'm going to use the print writer class. And so I do the same kind of thing. I open up a file, and then instead of doing new scanner, I say new print writer with that file. And then again, I put that inside of a try catch to make sure that it is safely done. And then when I want to use the print writer, output in this case is my print writer. When I want to use it, I just do a print line. I could do an output.print or an output.print line and use it the way you've used it for system.out. And what will happen is these characters will be written as a stream into our output device. It won't necessarily write it into the file right away. The operating system or Java will kind of decide when it wants to actually write it into the file. To guarantee that it actually gets written, you can say output.flush, which will flush whatever had been in the buffer. Or when you close the file itself, output.close will close the scanner object, and then that will then flush everything from the output buffer into the file. Okay? So again, there's many different ways of reading and writing files in Java, but this is just basically the simple ways that we're going to show and demonstrate that you can use in your own programs. Okay? So that's it. That's chapter 14 on files.